Something absolutely fascinating just happened in the weather modeling world that has meteorologists everywhere doing double takes at their computer screens. What if I told you that in the last 24 hours, our most trusted weather models performed a complete 180-degree flip that nobody saw coming? In the next 15 minutes, I'll reveal exactly what changed overnight, and at the 6-minute mark, I'll show you the incredible Pacific pattern that's driving this transformation. But here's what will truly amaze you. At exactly 11 minutes into this forecast, I'll explain the polar vortex phenomenon that could reshape winter across America. Right now, while most people assume winter weather patterns are set in stone, the atmosphere is rewriting its script in ways that haven't been seen in years. Welcome to the most intriguing weather mystery you'll encounter this season, as we unravel why our computer models suddenly changed their minds about January. Today's model runs are painting a dramatically different picture than yesterday, showing optimistic signals for cold and snow around the January 10th timeframe. Here's your first reward for staying with me. The European model has undergone the kind of pattern recognition shift that happens maybe once or twice per winter season. I'm looking at brand new data that came out just hours ago. And honestly, the transformation from yesterday's runs is remarkable to witness. The models are suggesting a major atmospheric reorganization that could bring significant changes. Though I want to emphasize, we should approach this with cautious optimism. Think of computer weather models like a team of meteorological detectives, and today they've uncovered clues that completely change the story they were telling yesterday. Before we dive deeper into these fascinating changes, let me share an important perspective. When models flip this dramatically, it often signals atmospheric uncertainty. The fact that our most sophisticated forecasting systems just perform such a significant about-face tells us the atmosphere is entering a particularly complex phase. Let's examine this morning's European model run, which shows considerably more optimism than we've seen in recent days for winter weather enthusiasts. Starting tomorrow, we actually have a small southern slider system bringing light snow showers across portions of Virginia during midday hours. This modest system will struggle to produce significant accumulation, likely delivering more visual appeal than measurable snow, but it's worth noting. After this minor event moves through, we enter a period where the atmospheric pattern begins setting up for more substantial changes. The ridge currently positioned over central states will gradually shift eastward around January 6th and 7th, bringing notably warmer conditions to eastern regions. A warm front set up along the East Coast will actually intensify this mild air mass, pulling temperatures well above seasonal averages. Don't expect significant cooling anytime soon. The first week of January will actually feature continued warming rather than traditional winter conditions. However, here's where the story becomes absolutely fascinating. Around January 10th, the models are indicating dramatic atmospheric changes begin. We're seeing the development of a major trough across central states with very cold temperatures that could fundamentally alter our weather pattern. The temperature maps show blues and purples spreading southward in ways that suggest genuine Arctic air finally gaining traction across the United States. This developing cold pool appears capable of supporting significant winter weather events, particularly across the plains, Midwest, and potentially northeastern regions. Cities like Chicago, Detroit, Minneapolis, and Milwaukee could experience their first sustained cold pattern since early December under this scenario. Cleveland, Buffalo, Pittsburgh, and Syracuse would benefit tremendously from this pattern, with enhanced lake effect potential and storm system opportunities. The Plains states, including Kansas City, St. Louis, Indianapolis, and Columbus, show increasing potential for meaningful winter weather events. Even cities further south like Nashville, Louisville, Cincinnati, and Lexington could see their winter weather prospects improve significantly. The models extend this optimistic outlook well into the second half of January, suggesting sustained favorable conditions rather than brief cold shots. However, I must emphasize that these changes are occurring very deep into the model timeframes, where uncertainty naturally increases. Given the recent instability in model performance, we should view these developments as encouraging trends rather than definitive forecasts. The European model's sudden shift toward winter optimism coincides with equally dramatic changes in the American GFS model system. I'm actually refreshing my computer page as we speak because the latest GFS run is so fresh that it's still processing while I create this forecast. This newest GFS data appears to follow the European model's footsteps, showing remarkable agreement on the January 10th timeframe changes. The GFS confirms that minor southern slider system for tomorrow, bringing light snow showers across Virginia with minimal accumulation expected. Lake effect snow bands will spread into Pennsylvania and New York with potential for snow squalls that could create temporary travel challenges. Sunday and Monday feature a clipper system tracking across the Midwest and Great Lakes before reaching northeastern areas. The warm period following this clipper is projected to be quite pronounced, with temperatures reaching the upper 60s and possibly 70s across the mid-Atlantic. This represents a highly unseasonable warm pattern that will make the subsequent cold contrast even more dramatic when it arrives. Interestingly, the GFS model shows massive snowfall potential for plains and Midwest regions around January 9th, creating a stark difference from the European model. This discrepancy between major models for an event only 6 days away demonstrates the atmospheric complexity we're currently experiencing. Residents of Kansas, Nebraska, Iowa, Missouri, and Illinois should monitor this potential system closely as model consensus develops. The GFS continues showing favorable winter weather development around January 11th and 12th, aligning with our previously identified time frame. Both models suggest a stream of storm systems moving along the East Coast during the third week of January with enhanced winter weather potential. If sufficient cold air becomes established, this coastal storm track could produce significant winter weather for major metropolitan areas. New York City, Philadelphia, Boston, and Washington, D.C. would all benefit from this type of pattern if cold air availability improves. The European model shows stronger support for this scenario, while the GFS remains somewhat less aggressive but still encouraging. Now let me explain the fascinating meteorological reasons behind these dramatic model changes, because the science is absolutely captivating. The key to understanding this transformation lies in Pacific Ocean patterns, where multiple ridges and troughs are reorganizing in significant ways. Around January 7th, we observe a ridge positioned east of Japan, a trough south of eastern Russia, and another ridge south of Alaska. This particular arrangement, especially the warmth south of Alaska, represents a highly unfavorable configuration for winter weather in the eastern United States. Additionally, a trough develops offshore of western Canada and the western United States, which further disrupts favorable winter weather patterns. For optimal winter weather in the east, we actually need the opposite arrangement: warmth along western North America with cooler air centrally located. However, here's where the story becomes remarkable. By January 10th, these Pacific patterns undergo a complete reversal. The European ensemble model, which represents 30 different forecasts averaged together, shows this transformation occurring with impressive consistency. This ensemble approach provides much higher confidence than single model runs, giving us approximately 30 professional opinions combined into one forecast. A strong trough establishes itself over western Alaska and extends southward into the central Pacific between Hawaii and Alaska. Simultaneously, warmer air develops along western Canada and the western United States, creating the ideal Pacific pattern for eastern winter weather. This configuration encourages the jet stream to adopt a more favorable position for storm development and cold air transport into populated eastern regions. Denver, Colorado Springs, Salt Lake City, and Boise would experience milder conditions under this pattern, while the East benefits from increased winter potential. The contrast between early January's unfavorable Pacific setup and mid-January's beneficial arrangement represents textbook atmospheric reorganization. Portland, Seattle, San Francisco, and Los Angeles would see their winter storm activity diminish as high pressure becomes more dominant. Meanwhile, cold air masses would gain easier access to central and eastern regions, supporting sustained winter weather patterns. The timing of this Pacific transition aligns perfectly with historical patterns that have produced memorable winter weather events. Meteorologists often look for these large-scale Pacific changes as leading indicators of significant atmospheric shifts weeks later. The fact that both European and American models are detecting similar Pacific evolution adds credibility to the winter weather optimism. This type of pattern recognition represents modern meteorology at its finest, using global observations to predict regional weather changes. Phoenix, Las Vegas, Albuquerque, and El Paso would continue experiencing mild winter conditions as the western ridge strengthens. The persistence of favorable Pacific patterns often determines whether winter weather becomes sustained rather than sporadic. Current indications suggest this beneficial arrangement could maintain itself through much of the second half of January. However, we must remember that Pacific patterns can change rapidly, so continued monitoring will be essential. The downstream effects of these Pacific changes typically take 7 to 14 days to fully manifest across North American weather patterns. This timing explains why models show the most dramatic improvements beginning around January 10th rather than immediately. Atmospheric waves travel across the Pacific at predictable speeds, allowing meteorologists to anticipate when changes will arrive. The complexity of these Pacific interactions demonstrates why weather forecasting remains one of science's most challenging endeavors. Modern supercomputers process millions of atmospheric data points to detect these subtle but crucial pattern changes. The fact that multiple independent modeling systems are reaching similar conclusions provides encouraging validation of these trends. International collaboration in weather observation makes this kind of global pattern recognition possible. Satellites, weather balloons, and ocean buoys continuously monitor Pacific conditions that influence our winter weather. The investment in global weather monitoring systems pays dividends when detecting these game-changing atmospheric shifts. Climate scientists study these Pacific-Atlantic connections to understand long-term weather pattern evolution. The current Pacific reorganization fits patterns observed during previous notable winter weather seasons. Historical analogs suggest that when these Pacific configurations develop, eastern winter weather potential typically increases significantly. However, each winter develops its own unique characteristics despite following similar large-scale patterns. The key is recognizing when atmospheric conditions align favorably rather than expecting exact historical repetition. Now let me share some additional fascinating developments that are supporting these optimistic winter weather trends. The stratosphere, approximately 10 to 30 miles above Earth's surface, is showing signs of significant disruption that could enhance our winter weather potential. A polar vortex weakening event appears to be developing, which historically correlates with increased winter weather activity. These stratospheric events can take days or weeks to influence surface weather, but their effects often prove quite substantial. Here's what's particularly exciting about this developing polar vortex situation. It's directing energy toward the eastern United States. This configuration differs from November's polar vortex event and more closely resembles patterns from previous winters that produced significant cold and snow. Last winter's polar vortex disruptions were directed straight into eastern regions, enabling some truly remarkable winter weather events. We witnessed historic snowstorms reaching deep into southern states, including blizzard conditions along the Gulf Coast. I'm not predicting identical events will occur, but this comparison illustrates the type of winter weather potential these patterns can unleash. The strength and direction of polar vortex disruptions often determine whether winter weather becomes historic or merely notable. Current atmospheric indicators suggest this developing event has characteristics similar to those memorable winter patterns. Birmingham, Montgomery, Jackson, Little Rock, and Memphis could potentially experience rare winter weather if these patterns fully develop. Atlanta, Charlotte, Raleigh, Richmond, and Norfolk would see dramatically improved chances for meaningful winter precipitation. The combination of favorable Pacific patterns and stratospheric disruption creates optimal conditions for sustained winter weather. However, I want to maintain appropriate scientific skepticism given the dramatic model changes we've witnessed recently. When computer models lose grip on atmospheric patterns, they often produce erratic forecasts before settling into more reliable solutions. The fact that we're just beginning to see these optimistic signals means we should remain cautiously hopeful rather than completely confident. Nevertheless, today's data represents a vast improvement over yesterday's disappointing model guidance. The consistency between European and American models provides additional confidence that these trends may have legitimate atmospheric basis. Professional meteorologists are watching these developments with great interest, as model agreement on pattern changes often signals genuine atmospheric shifts. The Climate Prediction Center's monthly outlook for January appears more consistent with today's model runs than yesterday's guidance. Government forecasters often detect longer-range patterns that computer models initially struggle to resolve consistently. The fact that today's data aligns better with official outlooks suggests these optimistic trends may have scientific merit. Precipitation patterns from the European model show increased activity across eastern regions, particularly through northward-moving storm systems. This upward storm movement typically correlates with nor'easter potential and interior snowfall opportunities. Here's what I promised to share at exactly 11 minutes. The polar vortex phenomenon represents one of nature's most powerful winter weather mechanisms. When the polar vortex weakens and splits, it releases tremendous amounts of Arctic air that can transform winter weather patterns across entire continents. The current developing disruption appears capable of directing this Arctic energy directly toward the eastern United States. This represents a fundamentally different configuration than earlier disruptions that affected different global regions. Stratospheric warming events occur when atmospheric waves propagate upward and disrupt the polar vortex's normal circulation. The timing and intensity of these disruptions often determine their surface weather impacts weeks later. Current indicators suggest this developing event has the characteristics associated with significant surface weather changes. The polar vortex typically strengthens during winter months, so disruptions represent departures from normal atmospheric behavior. When disruptions occur, they can persist for weeks or even months, supporting sustained winter weather patterns. The current disruption's trajectory toward eastern North America follows patterns observed during previous notable winter seasons. Scientists continue studying polar vortex behavior to improve long-range winter weather prediction capabilities. The combination of satellite technology and atmospheric modeling allows unprecedented monitoring of these stratospheric events. Public awareness of polar vortex phenomena has increased significantly following several high-profile winter weather events. However, not all polar vortex disruptions produce dramatic surface weather changes, which is why careful analysis remains essential. The current developing situation shows characteristics that historically correlate with significant winter weather potential. Storm systems moving northward along the East Coast would benefit tremendously from enhanced cold air availability. Interior regions often experience the most dramatic improvements when polar vortex disruptions provide sustained Arctic air masses. The potential for nor'easter development increases significantly when cold air becomes readily available and storm tracks remain active. Coastal regions from Maine to North Carolina would monitor these developments closely for potential winter storm impacts. The western United States would likely experience continued high pressure and mild conditions, while the east sees increased winter activity. This pattern represents classic continental-scale weather redistribution associated with major atmospheric reorganization. Energy companies across eastern regions would prepare for potentially increased heating demands if sustained cold develops. Transportation systems would benefit from advance notice of potential winter weather pattern changes. Agricultural interests would welcome the return of more seasonally appropriate winter conditions after the recent mild period. Winter recreation industries would monitor these trends closely, as sustained cold and snow could dramatically improve business conditions. Ski resorts from Vermont to Colorado would particularly benefit from reliable snow production if these patterns develop. The economic implications of sustained winter weather extend far beyond recreation into multiple sectors, including energy, transportation, and retail. Emergency management agencies would appreciate advance warning of potential winter weather pattern changes. Snow removal contractors and salt suppliers would prepare for potentially increased demand if sustained winter conditions develop. Insurance companies monitor weather patterns closely due to the significant financial impacts of major winter storms. Utility companies prepare infrastructure for potential ice storms and heavy snow loading that could affect power distribution. The social and psychological impacts of returning winter weather often prove as significant as the physical effects. Winter weather enthusiasts who have endured a disappointing season would celebrate the return of traditional winter conditions. Children hoping for snow days would finally have legitimate opportunities if sustained winter patterns develop. Families could plan winter activities and outdoor adventures with greater confidence in snow availability. The photography and tourism industries would benefit from scenic winter landscapes if snow becomes more reliable. Winter festivals and outdoor events could proceed with confidence if sustained snow cover becomes available. The cultural and recreational aspects of winter would return to regions that have experienced disappointing snow seasons. However, we must balance optimism with scientific caution given the recent volatility in atmospheric modeling. The dramatic model changes we've witnessed suggest the atmosphere remains in a transitional and somewhat unpredictable state. When models disagree significantly or change rapidly, it often indicates genuine atmospheric complexity rather than computational error. Professional meteorologists maintain healthy skepticism when model guidance becomes unusually volatile. The key is distinguishing between meaningful atmospheric signals and temporary model instability. Current trends appear to represent genuine atmospheric reorganization rather than random computational variations. The consistency between independent modeling systems provides additional confidence in these developing patterns. International meteorological cooperation ensures that multiple perspectives contribute to pattern recognition. The scientific method requires continued observation and verification before accepting dramatic forecast changes. However, the atmospheric signs are sufficiently encouraging to warrant serious attention from winter weather enthusiasts. The coming days will provide crucial information about whether these optimistic trends continue or prove temporary. Model consistency over multiple forecast cycles would significantly increase confidence in winter weather potential. The challenge in long-range forecasting is identifying genuine atmospheric signals among natural forecast uncertainty. Current indications suggest we may be witnessing a legitimate atmospheric pattern shift rather than random model behavior. The scientific community will monitor these developments closely to advance understanding of winter pattern transitions. Educational institutions use cases like this to demonstrate the complexities and challenges of atmospheric prediction. The intersection of Pacific patterns, stratospheric dynamics, and computer modeling represents modern meteorology at its most sophisticated. Students of atmospheric science will study this period to understand how multiple factors combine to create forecast uncertainty. The eventual resolution of these atmospheric patterns will provide valuable lessons for future forecasting challenges. Public education about weather forecasting uncertainties helps create realistic expectations during complex atmospheric periods. The democratization of weather information allows enthusiasts to participate in the excitement of major pattern changes. Social media enables real-time sharing of weather observations that help validate and improve atmospheric understanding. The weather community's passion for winter patterns creates supportive networks that celebrate forecasting successes together. Citizen weather observers contribute valuable data that enhances professional meteorological analysis. The combination of professional expertise and public enthusiasm advances weather science for everyone's benefit. This forecast represents more than pattern analysis. It demonstrates the ongoing evolution of atmospheric understanding. The accuracy of these predictions will be measured not only by snowfall amounts, but by the advancement of meteorological science. As we conclude this fascinating exploration of atmospheric pattern changes, remember that weather forecasting remains an evolving science. The dramatic model changes we've witnessed today highlight both the challenges and excitement of modern meteorology. Whether these optimistic trends materialize or prove temporary, we're witnessing atmospheric science in real-time action. The coming weeks will reveal whether winter weather enthusiasts' patience will be rewarded with sustained cold and snow. Thank you for joining me on this captivating journey through atmospheric complexity. And may the forecasting mysteries ahead prove as engaging as today's discoveries. Stay connected for updates as these patterns develop, because the most intriguing chapter of this winter weather story is just beginning to unfold. Until next time, keep watching the skies with curiosity and wonder, and prepare for the atmospheric surprises that make weather forecasting endlessly fascinating.